In this problem, what things do we not know? Because first, we might have, now granted, we told you this was systems of equations, but you might have an equation with just one variable that you can solve. First thing you want to question is, what do I not know? Because our unknowns we represent with variables. What's not known? Did you have your head up, Lily? So we don't know the number of kids' tickets, and we don't know the number of adult tickets. So how many unknowns do we have? We have 2. So right away, you know your equation's going to have how many variables? 2. Okay, so that's like the first thing, because you're not going to be told, like, hey, here's a system. This is the scenario. If you see this on, like, the park exam, it would just be like, boom, Gina went to the aquarium, figure it out. So that's how you're going to look and say, how many unknowns do I have here? Like, what's my attack, my plan of attack? So we know there's 2 unknowns. Good. Now what? Should we maybe, like, identify our unknowns?
I was gonna say, like, maybe you can kind of note adult that they give me a price basically for one adult ticket would be $20.
Okay.
And the children's ticket would be $15.
Okay, so we know based on the information given that adult tickets are $20, children's tickets are $15. Good.
So we know we have 2 unknowns. We have how many adult tickets and how many children's tickets. What do we want to do with those? How can we represent them?
Max.
Put a variable after.
They could be represented as variables because we don't know how many children's tickets, so we can just say that's an unknown. What do we want to say children's tickets are right now? We want to say children's tickets are X?
Yes.
Okay, let's try that. And what else?
Yeah, so then we can use Y for adult tickets. Good. Do we have to always use X and Y?
No.
No. Yeah, you can use C. You can use any variable really.
When we go through the steps after you kind of do it and then we recap it, you'll see that we didn't use X and Y. We used C and A. Why do you think sometimes we choose to use specific variables instead of X and Y? Did you ever hear that? Sorry, I thought I saw the hand.
So we know what we're talking about, like what are we referring to?
Right, because like at the end, imagine you go through this crazy lengthy system and all of a sudden you come up with like X is 5. There's a good chance that you're like, wait a minute, what's X? Is X kids or is X adults? If you don't know that and didn't have it specified or made a mistake in the process, it'll throw off your whole system. But if we label children's as C and adults as A, and at the end it was like, okay, C is 5, then we know like the children's tickets, there were 5 of them. It's a little bit more, it helps sometimes. For those of you that need that structure.
So Mortimer said that we know that adult tickets cost $20 and children's tickets cost $15. Can we write an equation?
You can do C.
So you're changing children's to C.
Yeah, C15.
How would you write that?
15C. Wait, no, 15C
Okay, so Mortimer says 15C
plus. Wait, no. I don't know how, like. Wait, no. 15C equals. I was gonna say cost, but C's are the other.
So think about what you know. Let's leave the math alone for a minute. What do we know? Max.
They got 20.
Okay, so we know that there were a total of 20 tickets. So let's explain that even more. The total number of tickets. And what kind of tickets did they buy?
Admission.
They bought admission tickets, but what kind? They bought children's tickets, and they bought adult tickets, and they bought 20 total. Good. What else do we know?
That the cost for the 20 admission tickets was $340.
The total cost for all the tickets was $340. Can I represent any of that information as an equation? Let's go back to what Max said. What did Max say?
That there were 20 admissions.
So Max said that there were 20 tickets total. So how can we show that as an equation? This is where systems gets a little tricky because you do need to know how to put the equations together, which is why we practice.
It could be like A plus C equals 20.
Why A plus C equals 20? He's right. A plus C equals 20. What does that mean?
The amount of tickets that we get should be 20.
Right, and we know that the only tickets they bought were what?
20.
The only type of tickets.
Oh,
They only bought adult tickets and children's tickets. So whatever combination of adult and children's tickets combines to give us 20. Does that equation make sense? Yes. What else? Now think about the only other information left. Deals with what? The total cost. So how can we represent the total cost? They spent how much money total? They spent $340. And what they buy?
Children tickets.
They bought kids tickets or children's tickets, and they bought adult tickets. So let's represent the price. How do we do that? Say it again.
Wouldn't it be 15C?
15C, because what does that represent?
The total
The cost of the kids tickets, and then what else?
plus
Plus
20
Plus 20A, because that represents
the cost of the adult tickets.
cost of the adult tickets, and that has to equal what?
340 because that's the total.
$340. So that's the tricky part with systems. Because what you did is first you identified that there were two unknowns, children's tickets and adult tickets. Then you needed to take all of the information you were given and create equations to represent. And this takes time. Most of us are like, oh, we get substitution, oh, we get elimination, I can even graph it. And then we get to this and it's like, wait, what? This is what takes the most time with systems because we struggle, and I'm just generalizing here, we struggle to put the words into equations when you're given so much information. You're used to getting an equation like the temperature was this amount, and then it went down to this amount. What's the new temperature? That's straightforward. Now you're given a lot of information, and sometimes you'll be given even more information than you need. So it's important to learn how to pull the information that's specific for the scenario. I feel like we broke it out with all of this.
Okay. So. Alright, so now we have our two equations.
If you don't have these written, write the equations down.
So what do these two totals represent? What is this? What is this? I'm just recapping. We already kind of talked about it.
The first equation is the adult tickets plus the children tickets equals the total number of tickets.
Equals the total number of tickets, 20. And then what about this total?
The cost of the children's tickets and the cost of the adult tickets equals to 340.
Equals 300.
If you went through and like if you saw that word problem and you just like crossed out the information as you wrote an equation, like you'd have nothing left. You literally used every bit of information in there. You used the 20, you used the idea that there's adult and children's tickets, you used the 340, you used the adult ticket cost of 20, and you used it all. Okay, and so as you're breaking these down, and I know this becomes the struggle. When you're going through and writing your equation, it's okay to actually like mark through the word problem. Say, all right, I use that information, I use that information, because the information is going to be there primarily for a reason.
So how can we use these equations to find the total number of adult and children's tickets?
You can use substitution.
Yeah, we can use substitution.
Do you have to use substitution?
You could use elimination, but it does take a little longer.
Good, it's totally your preference.
Whatever you want to do.
What should we do?
What do we want to do?
I say substitution.
Substitution?
All right, Max, what do you want to substitute?
So what do we need? What do we need to do? Do we have a value that we can substitute right now?
No, we would have to change the
change the form of the equation. We wanted to say A is equal to something or C is equal to something. So what can we do here? Okay. If we use this first equation, this one's a little bit easier to isolate a variable rather than this one. Does it matter which variable we isolate here?
No.
So it's obviously you want to subtract C from both sides.
So
And what is A equal to now?
20 minus 6.
20 minus 3. Okay, so now we know that A is the same as 20 minus C. What can we do to find?
Now that we know, like, a general, like, not the value for A, but, like, a general value for A for now, we can substitute that value into the second equation
For what?
for A.
For A. Alright, so instead of this A here, anywhere you see an A, instead of an A, we have what?
20 minus
20 minus C. So what's our new equation?
20 in parentheses 20 minus C plus 15C equals 340.
You'll see on a lot of these that the method we go with is substitution because that's our preference. I think like all of them we do substitution. It does not mean you have to. If you did elimination here and you still got the same answer, you'll still get the same answer. Totally your preference. But you'll see substitution a lot because that's what we like.
So now how can we solve this? What can we do to solve this? Distribute. Okay. Distribute the 20. What do we have?
400 minus 20C plus 15C equals 340.
Alright. Now what's next? Combine like terms. What are our like terms?
Negative 20C
Negative 20C and 15C. So what is our new equation now?
400 minus 5C equals 360.
In sync, I love it. Okay. Alright, now what?
Subtract 100 on both sides.
Subtract 400 on both sides.
Negative 5C equals
Okay. Now what? Anybody else has like this?
wow.
Sorry, you guys just did answering every question.
I know it's empty right now, but it won't be for long.
C equals.
12.
C equals. So what does that mean? We have C equals 12. What does that mean in the context of our scenario?
That there is that they bought 12 tickets.
Okay, so they bought 12. What kind of tickets? Children's tickets. Did we answer our question? Our question says how many adult and children's tickets did the group buy?
No, we just have to find part of it.
We just answered part of the question. So we know that they bought 12 children's tickets. So now what can we do to find how many adult tickets?
You put 20 minus 12 equals 8. Or you could put
Okay, we substitute the 12 in for any C. Alright, so Marco used this equation. So he said instead of a C there, we're going to put in a 12. And we know that A, which is our adult tickets, is equal
8.
8. So how many adult tickets? 8. Now did we answer our full question?
Yes.
Okay, so we know that we bought 8 adult tickets and 12 children. Oh, how can we check that that's right? We said A and C equals so.
Myra, how can we check?
Okay, so A for 8.
So that one's pretty straightforward, like total tickets, 8 and 12, good. We still need to check the cost. How much did we spend on adult tickets? How do you know 160?
multiply
Like
20
20
by
8 tickets, $20 each, 160. How much did we spend on children's tickets? 180. How do you know 180?
Multiply the 15 times 12. Because
Yeah, $15, 12 tickets. Does 180 and 160 combine to give us 340?
Yes.
Yes, it does.
So we know that our variables work in both equations. Okay, so good. So now we're gonna practice in our groups. We have a new scenario here. Dan stocked up on batteries. He bought 8 packages of batteries for a total of 62 batteries. The AA batteries are sold in packages of 6, and the AAA batteries are sold in packages of 8. We need to write a system that can be solved to find how many packages of each type of battery that Dan bought. So don't forget to first define your variables, and then write the 2 equations, our system of equations.
So work together as you go through this because, again, we know that the struggle, and maybe not for all of you, but this is a general struggle, is putting together the actual system algebraically. To take the information that's provided and represent our 2 unknowns in 2 equations so that we can solve. So work together and try to put together equations to find your solution. Let's take a few minutes on this and see what we come up with.
Here's the battery. And now we know that you bought AA battery. Call the AA battery. Yes, and we already know that he bought six. So it's 8.
Right? I just saw it. That's funny. So everyone should have 2 equations that can represent this scenario. Work on putting the equations together first. Perfect. That's all.
Wait, no, this one's 8. Yeah. Yeah, I'm like, wait a second, I looked at how long. I got you. Now, let's do elimination. What?
No, because when you substitute, no, you know what? I would say I would use like so. You don't have to guess that way, X, Y, but whatever you do, put it at like the beginning of somebody. If you come up with like X, Y, you're like, okay, well, so that you can do that. I would not say do not make your variables AA and AAA. Right? Your variable is just
I will.
really not funny.
Yes.
The reason being, if you have a system that you need to like distribute, that can get very confusing very fast. So if you're going to identify it as like an X or a Y or a Z or a V, whatever it is, you can write it at the top like, okay, AA is going to be this variable, AAA will be this variable. It'll make it so much easier when you get your solution.
You can get everything, but there's two ways to do it. You can It's seven. It's seven.
Because you're subtracting 64 times H is 14.
And A is one.
So you did why?
Which one? Which one is that?
Okay, so let's stop where we are really fast. And we're gonna what are our equations? What are our equations for this word problem? Oh, there's clever. What is alright, so you said A plus B equals 8.
And then
But what is A and what is B?
A is what is A? A is the double A and triple A is B.
Okay, so A is double A.
And this matters because if at the end you switched it, your entire system would be different.
And B is triple A. Alright. So we have A plus B equals 8. What does that mean? That's not mathing.
Not math.
That the amount of packages for each type of battery is, there's 8 packages.
8 packages total. So any combination. What are examples of our combinations?
2 and 6.
Good. 2 AA, 6 AAA. Maybe 2 AAA, 6 AA. Maybe 5 and 3. Maybe 4 and 4. Maybe 1 and 7. Right? Any combination. But there's more to this scenario. What else do we know? You can help us with our other
No, we know how
equation.
many batteries.
Go ahead.
For double A batteries, there's only packages of 6.
Double A's are sold in packages of 6, and triple A are sold in packages of 8. What else do we know?
That the total batteries was 62.
The total batteries are 62. So how can we use that information to help us? Go ahead. 6A. Now this is where it really matters. The variable is not as important in that first equation, whether it's like A plus B equals 8 or B plus A, but now it matters. Because when Rogelio says 6A, what does that mean? Why 6A and not 8A? Why does it matter now?
The A is referring, the A represents the double A battery.
So why does that matter when we put it in with the 6?
Double A batteries are sold in packages of 6.
Right, the AA batteries are sold in packages of 6. So this is where the variable and the coefficient are really, really important. Good. Okay.
6A plus 18
Good.
equals 62.
And so what does that mean now? Rogelio says his equation is 6A plus 8B equals 62. What does that mean for this scenario? What does that mean? Say this in a sentence, in words.
That we have the batteries equals 62.
Like, what does 62 mean?
Like the total batteries that
Okay. So there's 62 total batteries.
And how are we getting that total?
like
says in the equation total of 62 batteries.
Yeah, so the total of 62 batteries, and what does this part mean?
Our variable A and B, what does A and B represent? The number of packages. So A and B do not refer to the number of AA batteries and AAA batteries. A and B, our variable, is the number of packages.
So what does the coefficient of those variables represent?
The number of them
The number of batteries in each pack. Yeah. Good. So now I want you all to solve this using substitution, and then I want you to also solve it using elimination. So we want to practice both. So if before we give you an if you have already did one of them, we want you to try the other.
A lot of us lean towards substitution here. Try elimination too.
Wait, which one did you do first? Elimination or substitution?
If you're having any trouble, raise your hand.
You did substitution, now do elimination. So if you do elimination,
I want you to practice both substitution and elimination.
So this would be right? Yeah. Yeah, it was just the calculation because you ended up adding like this 126 you would be adding 62 plus a Yep. Yeah. So this is substitution. This is elimination. It's a really good review of like the first unit, just pulling in like jump in.
Also,
Yeah.
Okay. So let's go over. Let's do elimination first. What do we do?
So, so now you said A and B. I was gonna say X and Y.
That's okay.
So I took.
When you add these together, does anything eliminate?
No.
We added these equations together, so I don't eliminate right now. What do we have to do to make them eliminate?
Okay, so what I did was the first equation A plus B equals 8. I multiplied it by a -6.
Why did to multiply by -6 the whole equation?
To get rid of the A.
Because when we add them together, what do we have now? What's in the equation?
negative
six A
plus,
no,
no,
minus
minus
negative
six
six
equals negative 48.
Notice we multiply the whole, every term, the entire equation, both sides of the equal sign, you can multiply. Alright, so now let's add these together and see if anything eliminates. Alright, so if we added these equations together, does anything eliminate? So we have negative 6a plus a positive 6a. What do we get? How many? Zero. Okay. Now we have negative 6b plus 8b.
2B.
Or not. Negative 48 plus 62.
14.
14.
divide by two.
Divide by 4.
B and B equals 7. Are we done?
No.
No. What do we have to do?
So what I did is for the first equation I put, I wrote A equals 8. Like I wrote A equals 8 minus B.
What did you do first? Without rearranging, what did you do? We know that B is equal to 7. How can we find an A? We don't necessarily have to rearrange anything.
So take the second option, the second equation,
Okay.
and plug in B and 7.
Doesn't matter which equation.
No.
No. Alright, so the second equation, instead of 7, we're plugging instead of B, we plug in a 7. What do we have?
6A plus
6B plus 56.
Which equation do you think would be easier?
First equation.
Probably the first one, right? Like if we quickly substituted instead of B is 7 here. What's A?
1.
A equals 1. Okay, so that was our elimination. Does anyone have any questions on that? I know you might. We'll talk later. You good?
No, he's good.
Oh, good. Awesome. All right. So now let's do substitution. So our two equations.
I don't like substitution. Oh.
Okay. So how do we substitute? What do we do? Is there anything that we can just that we know about either of these variables right away, or do we have to make some changes? Okay. So what do we want to do?
From the first equation, subtract B from both sides.
Yeah, we subtract b from both sides in that first equation. What's our new equation?
A equals 8 plus B. Minus B.
A minus b.
Make sure you can do both methods, so follow on. Just make sure you got it right.
All right. So we have a equals a minus b, and then we have this equation 6a plus
8B.
8b equals 62. So what can we do? Now that we know that a is the same as a minus b. What can we do? We're trying this way, the substitution way. We already know our answers.
But pretend like you don't.
Oh, pretend like you don't. Yeah.
Oh, 6. Second equation. 6A equals 62 minus.
So pretend like we didn't already solve this. We don't know anything. We're trying to do the substitution right now. So we already rearranged and solved for a. So we have a equals a minus b, and then we have this equation. What can we do to solve? Okay, so what would that look like? So anywhere we see an A, we can just replace it with 8 minus B. Now can we solve this? Yes. Alright, what do we do?
Distribute.
Alright, so we can distribute 6. Anytime we see parentheses, we can distribute.
So what do we have? I I know what you guys are, we do have the answer, we still wanna make sure that the method's there.
48 minus 6b plus 8b equals 62.
And simplified, what do we get?
48 plus 2b equals 62. I want to subtract 48. 2b equals 14.
So B is,
b is 7.
And then we write down that A is 1, we did it before. But if we didn't know, what would we have done at that point? We would have plugged in 7 for anywhere you see a B to find A, or A, yeah. Whatever you label. Okay, good. Does anyone have any questions on this right now?
Okay, so, alright, so you know that. So I was asking Evan, my fellow student, Evan Woe, I was asking him like how would I know that it's gonna be x plus y, it's only x plus y for the second equation?
For
X
this,
plus y equals 8, yeah. Like you just,
let's go back to the word
you
problem.
just put that.
so it's all about pulling out the information. We always wanna start by identifying the unknowns. The unknowns here are the number of packages of AA and the number of packages of AAA. And usually that's told in like the question itself, where it says, solve how many packages of each type. So the information at the top where it says he bought 8 packages of batteries, that's the key. So if I don't know, if my two unknowns are the AA packages and the AAA packages, I do know that he bought 8 total packages. So that's how I pull that information. And then the 62 is the individual batteries.
Was it easier for you to write the second equation? Did you write that one?
No, it was easy for me to get like the first equation.
This one.
6, yeah.
So if you notice, if we went and wrote that equation and crossed out, there's still information left. Like it then says bought 8 packages of batteries, like that needs to be put somewhere.
And think about what you know, and like try to remove the math from it, and think about just, I don't want to say common sense, but if he only bought batteries, he bought 8 packages of batteries. The only kinds of batteries he bought were AA and AAA. So the total packages would have to be a combination of those two, which is where you would get like the A plus the B equals 8. Okay. And we'll do a lot. The breakdown of the word problems is the most challenging part. The solving of the systems tends to be much easier. But getting the equations is the challenge, and that's what we're working on this week.
Oh, okay, so
So we're gonna we have not really had an opportunity to do a ton of Galactic Heroes, so we're going to do that now. You did not get the menu because the menu is online. We kind of like eased our way through. If you go to the website, the Galactic Hero Unit 3 menu is online. We're focusing really on learning Target 4 because those are the real world scenarios. There are a ton of real world systems to practice. Okay, so if you choose to do the workbook that is part of the Galactic Hero, you may do that. We'll pull out the page numbers specifically that we're working on now and put them on the smart board. But everybody else, grab a laptop and take a look at the menu and start one of the assignments. And you might be able to finish some of them. But grab the laptops and start your Galactic Hero. I'm going right to the real world ones.
Right. I believe it.
No.
Okay, I take my glasses first.
No, because it was probably one.
the work from the smart board, for to do the work